Hello and welcome. I hope you're logged into everything that you need to log into. The first thing is this. I think I see about says there are some 15-16 participants in the Zoom call. You have to be on the Zoom call, and you should also go to joinpd.com. Trying to figure out where the chat would be. Oh, there is a chat. Joinpd.com, and the code is QGJUBP. Okay, that's the code. QGJUBP. It all looks the same in this font, but I hope you can distinguish it. Make sure you've joined there as well. I hope people can see the screen and see some 20 participants. Okay, thanks Mukesh for the confirmation. Let's wait for just one more minute. Give it some more time, maybe a few more people will join and then we can go through. So please join on joinpd.com as well. The code is put up there for you. You will have to respond on that. I hope you will respond. It's a slightly unusual time for the live session, so I'm not sure if people are going to be able to join. Let's see whoever joins. Okay, so I think we should get started. So welcome to this session. Thanks for joining. We'll go over the problems in the area of hypothesis testing in this session. And before we begin, I put a file here. I think, can you click on this file? Okay. Okay, yeah, seems okay. I think you can still see the. Can you see the screen still? Okay, good. So this is a quick roundup of the formulae, and what I'm going to do. So you see there is the z-test, and there is the t-test when you don't know the variance, and then there's the chi-square test for the variance itself, and there's two sample z-test and two sample f-test, and chi-square goodness of fit test and test for independence. So this all these tests I've gone through in the lectures, and the formulae are here. I'm just trying to see how to hold on 1 minute. Okay, just to move to the other tab. Okay, let's go. Okay, so this tab is something that's open for you, and what I will do now is maybe where I'll do something which is slightly. So what I'll do is I'll take this link and put this link on the chat here. So this is the link to the hypothesis testing file. Okay. Formula file. So I will suggest that you click on this link and open this file and keep it ready. Okay. So you may have to switch between that file and the presentation here when you're answering questions and the Zoom window, etc. And this file has all the formulae for you. So don't ask me for formulae in the middle of the lecture. All of them I've given to you right away. Click on this link, go to that window, and that will simply have the formulae for you. Okay. I hope this is clear enough. So I don't have to keep reminding you of the formula. And we're going to go through situations where all these tests have to be applied, like only very few situations, about maybe 4 or 5 of them, 6 of them maybe. And then we'll discuss that. Is that okay? I hope this is clear. Okay. So let's move on. I think I did have a chat window, and for some reason this chat just keeps disappearing. I don't know what to do. How do I bring back the, okay. Okay, I hope this is all right. So let's move on. We'll move on to the first question. So the first question is on this screen right now, and you know what to do. You need to go to joinpd.com and you will have a place to put in your answer. So there was a news item that I think I saw this yesterday, which claims that India's vaccination coverage has crossed 48 crore mark. So, so if you look at the Indian population for above 18, it's about 90 crores, maybe more, maybe less. I don't know, just estimating 90 crores or so. So if the vaccination has crossed 48, then the claim really works out to something like the fraction of people vaccinated is 0.53, right? So we may want to test this claim and see if it is convince ourselves whether it's true or not. If you are doing that, what will your null hypothesis be? What will be your setting, and what will be your null hypothesis is the first question. Okay. So your setting now will be clear, right? So you're going to now sample some people and ask them whether they're vaccinated or not. You may have n samples, right? And each sample will give you a 0 or a 1 answer, and you can call this x1, x2, xn, which will be Bernoulli P, right? Now that is the setting, right? So you should first write down that setting whenever you're faced with a problem like this. And the null hypothesis says P equals what? That's the question, right? So please go to joinpd.com and put in the code QGJUBP. Then you'll be able to enter your response. So once again, the setting, when you start surveying to find, to do this kind of testing, you probably have n samples, x1, x2, xn, each would be Bernoulli P, right? And that's going to be your setting, and then the null hypothesis will be P equals what? That's the question. So typical null hypothesis in such cases will be the what is claimed to be the ground truth, isn't it? So it's okay. So let me wait for a couple of more minutes. There's no need to look at the formula and all here. It's the ground truth is given. You're going to go ahead and sample. When you sample, you have this model, the IID model for your sampling. In this case, it's Bernoulli P, whether someone is vaccinated or not. The ground truth says the fraction vaccinated is 0.53. The null hypothesis is going to be P equals what? Okay, so let me just see the responses. P equals 0.53. Okay, so so 91. Okay. So be careful about 91 and all that, right? Nobody is going to be able to sample all the 91 crore people. Okay, Okay, so your number of samples will be much smaller than 91 crore or something. I just used 91 crore to roughly give you that fraction 0.53, right? So P equals 0.53 is going to be your null hypothesis. Null hypothesis is always the ground truth. You believe the null hypothesis, right? So it's not just 48. So you have to say H0 is P equals 0.53. So have a model for your sampling, and according to that model, your null hypothesis is P equals 0.53. So that's perfectly fine. Okay. So now comes the next question. The same setting, same situation. As usual, a skeptic from, say, I don't know, the opposition parties or something like that, is going to suspect that the above fraction is too high, isn't it? So then what will your alternative hypothesis be? So if you belong to this camp, which suspects that the above fraction is too high, your alternative hypothesis will be what? So once again, so this is the ground truth. You want to evaluate whether it's true or not. You're going to go and sample, and you may pick some N people to ask a survey question on whether they're vaccinated or not, and you will get N responses. So X1, X2, Xn, you're expecting to be IIT Bernoulli P, and you've already fixed a null hypothesis P equals 0.53, and your alternative will be what? Okay, a lot of people have responded, so let me just quickly show you. Somebody is asking, why can't the null be greater than or equal to? Yeah, cross is 48. Yeah, it could be greater than or equal to. Sure. Yeah, you can keep it like that too. But usually the null hypothesis, you want to keep it simple. If you keep it composite, that's a bit more confusing. But anyway, the 0.53 will sort of be the worst case null hypothesis, right? So I'm happy if it's 0.53. It could be greater, but 0.53 is sort of like the minimal thing. So it's good to keep, I think, the null hypothesis simple. It's a good idea. Okay. Okay. All right. So let's see the responses. P less than, okay, not equal to. I don't want to say not equal to. Okay. So like I'm saying, I'm suspecting it's too high. So I want to say it's less than. I mean, if it's greater, I'm happy, right? So there's nothing much to worry about. So, and as the way the question is phrased, less than 0.53 is so greater than 0.53. I mean, one can argue it's a valid alternative hypothesis, but not in the setting I'm describing. The setting I'm describing, the person is suspecting it's too high, so he wants to have an alternative which is less than 0.5. Think that through a little bit carefully. You will get it. Okay. So let me hide the responses. Most people have said P less than 0.53, and that's correct. Okay. In the next slide, we're going to do something which is revolutionary for a live session. We're going to do a live survey. Okay. I think there are some 20 people in this group right now. It says 30 here in the participants. So let's say there are 30 people in this group. I'm going to do a live survey. Okay. So in all these questions, I've been giving you toy questions with, just giving you the survey results, making up survey results and saying, asking you to do calculations. Here is a live survey. Okay. So what is a live survey? There's a form here. And are we all over 18? I hope so. I think, I mean, only if you're over 18. I mean, if you're over 18, please respond. I think most people are over 18. So anyway, under 18, you cannot get vaccinated. So it's not reasonable to do a survey with under 18. So please click on this link. I hope you can click on this link. I think it is a clickable link. Can you click on it? If you can't, I will paste the link. Nope. Okay. So let me paste. Oh, some people saying yes, some people saying no. Why is that? I don't know why. Can someone copy the link and put it on the chat window, please? I could do it, but if I do, my screen will change. Yeah, from join PD, you should be able to click. Okay. Yeah, so there are other questions on the form. The first question is the most relevant right now. You can also answer the other questions. I'm happy if you answer the other questions because we'll need the other questions in the rest of the session. We will use those survey results for doing some more tests. But let's begin with the vaccination status. Please respond to that. I'm going to switch to the survey results screen and show you what the results are. I'll give a couple of minutes for people to go fill up that form. So at least fill the first question, which asks your vaccination status, and you will see. Okay, so let's see if people are responding to survey. Getting people to respond to surveys is one mega exercise. I think these are the things that nobody tells you. It's you have to really chase and okay, there you go. Oh, people have responded. People are responding. Okay, so let's see. So I think I've got about 27 responses, which is not too bad, and 28 more people are coming. I mean, don't put 74. I think above 75 and all that. I mean, I can't compute averages with that. So somebody has put 74, I think, and above 75. So it's difficult for me to compute statistics with that. But anyway, I mean, I will change it later. You can also change it. Just enter numbers or something. Okay. Let's see. So how do you count the number of S's? I think it's stable now. I don't think we'll get any more than 30 responses. What do you guys think? 32 it says. Anyway, let me stick to the first 30 responses. And I'm going to stick to the first 30 responses now and then give you how many S's. Come on, tell me how many S's are there. So painful. How do I? Okay. So there's 20 have said 20 have said yes, and then 10 have said no. Okay. So you can see the survey results. I hope the survey results are clear to everybody. I've just marked the first 20. Okay, there's one more person. I mean, let's just, I don't know, I feel sad about it. The person has responded very late, or maybe I should include them also. So we have 31 samples, and out of the 31 samples, 21 have said yes, and 10 have said no. Is that okay? 21 S's and 10 no. 21 S, 10 no. Is that okay? So you've got the results of the survey. So the live survey, we're doing exciting things with live surveys and all that, which we've never done in the past. So let's go back. Oops, I went to the wrong one. Should go to the presentation session. Okay, there you go. So we did the survey and you got the results. Now, with this result, I want you to answer these kind of questions. So now you're going to now start using the survey result in your test to figure out and conclude whether or not p equals 0.53 is you're going to accept that or you're going to reject that. So what will your test be? What will be your condition for rejecting null, and what is the p-value? Okay, and what's your conclusion? So take some time. So you remember the samples, right? You remember 31 samples, 21 S and 10 no. Putting it on the chat as well for those who couldn't see the screen share. We sampled 31 people in this call, and 21 have said yes, they got at least one dose of vaccination, and 10 have said no. Okay. So think a lot about your assumptions about the data. Okay, so I think in a survey like this, that's probably the most important thing. Right? The calculations and what you do after that are also important. In a basic statistics course, you should know whether or not this is how to do the calculations. But more importantly, reflect a little bit on the nature of the data. We could probably conclude it's IID and all that, but really is the data representative of India is an important question. We're talking about people who are attending a live session in a statistics course in a particular program offered by IITM. So in my opinion, it's really not a representative sample. It's a very sample which is probably, yeah, you can see more than 2/3 are vaccinated, right? So I think it's a completely different type of sample. But nevertheless, let's just see whether the conclusion is correct or wrong. So people are working it out. Yeah, the samples are good. 30 is good. It's a good enough sample. Hard to do hand calculations with 30. So I'll help you out with the calculations whenever we have to. But yeah. So it's that part is okay. See, the part that's tricky about sampling is not the number. You can get numbers, but is it the right number is the question, right? Otherwise, you'll get something else, which is when you have a diverse population. There's a theory on how to do this kind of sampling. If you do management courses, and they'll tell you what first you have to segment the population, and then there are different segments: rural, urban, educated, not I mean education of different levels, genders of different types. It's all, you have to mix up a little bit, and there is a theory to how to do these samplings to make sure it's representative of the general population. So if you close your eyes and pick one random person from India, right? So you do 30 repetitions of that, right? Are you likely to get people similar to the 30 people we have on this call? My hunch is no. I mean, I'm going to say no. I don't know. You think about that, right? If I want to claim that my data represents India in some sense, then I have to worry about such things. So those things are very, very crucial. And if you say, okay, within the BSc population, what is the fraction? Then this is probably a reasonably representative sample, right? So otherwise, I think people in this call probably don't represent the entire country. Anyway, that's a different point of view. Let's see what people are saying. There's about 6 people who have responded. You have to use, you can use a normal approximation. Okay. So there's something about, okay, somebody is sending me a message about 45 plus and 18 to 44. Yeah, that's true. That's also true. I've not taken care of that as well. So that could be also okay. So people are slowly responding. So you can use a CLT, normal approximation. Don't worry about exact binomial calculation and all this. A lot of samples here. But binomial is also fine. If you can do it, it's 31 is not so high, but still it's high enough. You can use CLT. CLT will give you pretty good approximation to the binomial even at 30, 31. So it's not a problem. So let's see, I've got about 9 responses. I'll wait for a couple of more and then show you what people have got. Okay, so Debasprit Mohanty, please don't respond with answers on the chat. You have to go to joinpd.com. Can somebody put the code for joinpd.com to help out Debasprit here? Yeah, joinpd.com, QJJ. Yeah, thank you. Okay, so let's see the answer. Many people have not fully computed. I think, I hope. Yeah, people are doing. Okay, so there's one FC inverse going on here. This looks like a reasonable calculation. Okay. Wow. Okay. So, I mean, I was just telling you all those stories about sampling and all that. People seem to be taking that too seriously. Don't take that too seriously. Those are just suggestions given. So you have to believe in your samples and go ahead and do the test. Okay. Don't worry about all these unknown. So no. So this is not a. So you have to use a CLT approximation. There's no need to do So sigma square is just NP into 1 minus P, right? Okay. So let me show you my solution. I think people are a little confused on how to exactly do this calculation. So let me show you my solution. My solution is a little bit more complicated. So maybe what I'll do, I'll go to the next question also, and then I'll come back. Okay. So what you have to do is, see, n is 31. Okay. The number of samples is 31. Given the null hypothesis, P is 0.53. Okay. So your mean is NP, and your sigma square is NP into 1 minus P. Is that okay? So you have your mean and sigma, and you use CLT for you use the normal approximation to binomial, okay, for your calculation. So after that, it's just a simple p-value calculation, right? Probability that, some t is greater than c, given or t is less than c in this case, right? You want to say it's less than. So it's just FC. It's just a simple normal calculation. I hope that's clear. If you haven't done this calculation before, this might seem a little bit tricky. So my solution is actually not so detailed, or maybe I could write it down, but the problem is my solution to the next part is also included in that page. So what I'm going to do, in spite of people not doing this very well, is yeah. So I've not mentioned about your approximation, but yeah, you should use the approximation. But anyway, so I have one more question for you. So maybe this case. So why don't you work on this problem, and I will show you the solution. When I show you the solution, I'll talk about how to do mean and variance and all that. I think people have figured that out. Maybe this is an easier question because I've told you what approximation to make. If I don't tell you, you feel uncomfortable making the approximation. Normal approximation to the Gaussian distribution. That's totally wrong. I mean, to the binomial distribution. I'm sorry. I didn't mean normal approximation to Gaussian. Normal approximation to the binomial distribution. Okay. So in the same test, I want a type 1 error probability of 0.05, and I want a power of 0.95 against the alternative for a fraction of 0.45. Oh my God, there's too many typos here. I apologize for that. There should be a fraction of 0.45, and this is not the Gaussian distribution, this is the binomial distribution. Okay. Yes. So the question is about 30 is usually a good approximation for at least in binomial. For normal approximation to hold, n equals 30 is a pretty decent number. Okay. It's something that people use. Okay, so this is probably a much more textbook problem. It's clear to you what to do. 0.53 is the null assumption. 0.45 is the alternative assumption. I want a type 1 error probability of 0.05. I want power of 0.95 against 0.45. So how many samples do I need? Okay. This will need a little bit of working out. So I will always advise you to have a window open where you can compute FC. I normally use a terminal with Python running and import SciPy stats on it, and for doing quick FC calculations, or you can leave your answer in terms of FC. That's okay. That's okay as well for the purposes of this live session. Okay, so this is a kind of problem, a very important textbook problem in statistics. You want to do a test between two simple hypotheses in this sense. One is that the fraction is 0.53, the other is 0.45. And you want a certain type 1 error probability and a certain type 2 error probability. Power is another way of stating type 2 error probability, right? So how many samples do you need? Okay, I've got an answer. Let me see if people come up with the same answer. So here you can use the normal approximation. Remember, it's binomial, right? So the mean will be NP, variance will be NP into 1 minus P. So you can use calculations for mu and sigma. Oh, n equals 31. Okay, so don't go to 91 crore. Oh my God. See, what is n? N is the, see, okay, so a couple of things to remember about this, okay? So if I could sample all the 91 crore, I don't need any statistics, right? I have all the data with me. I know the exact fraction. I don't need any statistical extrapolation. Now, I cannot sample all the 91 crores. There is some data being given about the number of people who are vaccinated. I'm taking a small survey, and from there I want to extrapolate and say, okay, you know what? I asked 31 independently and identically chosen people from this population on which you're claiming this 0.53 vaccination percentage. I found 21 people were vaccinated and 10 people were not vaccinated. From that, can I extrapolate and say something about the overall statistics? That's the sort of question that you address in statistics, right? If you can ask all the 91 crore, it's just a data collection exercise. This nobody can do that. So that's why the statistics enters the picture. Okay, so n is definitely 31. Okay, keep that in mind. Don't go into this other thing. Okay, responses are slowly coming in. I think pay attention to this formula for type 1 error probability, formula for power. Okay, and there will be a dependence on n, and figure out how the dependence on n comes. I mean, usually it's some sort of normal approximation. Then you will have a root n showing up in the standard deviation, n showing up in the mean, and all that. So you have to do that correctly and carefully. You can work with fractions, and you can also work with numbers, number of people. So for instance, you could work with 21 by 31, or you can work with 21 itself directly. Multiple ways to do this kind of approximation. So let me give one more minute. 2 people have responded. Nobody else has closed the calculation. So let me see. Okay, so the 4 people who responded, let me not take too much time. We will have an opportunity to do it. Okay, there you go. Oh, quite daunting. Okay. Okay, all right. So let me maybe show you. I think people are still figuring it out. Let me show you the working out, and then I'll go over this in some detail. Okay, so this is the setting, right? So proportion of vaccinated adults is claimed to be 0.53. What is the setting? I'm going to go ahead and survey some n people like I did over this call. And x1, x2, xn is Bernoulli p is my assumption, and p is like the fraction of vaccinated people. My null hypothesis is p is 0.53. If you suspect it to be too high, alternative is p is less than 0.53. And what's my test? Okay, so this is what's most important. I think this is the part which I think is confusing to some people, because I mean, the setting, sometimes people don't appreciate the setting when you teach it. So I just did a survey, right? What was my n in the survey? My n was 31. Come out correctly there. Okay. Isn't it? My number of people in the survey was 31. And what was my t, the test statistic? It's x1 plus x2 plus xn, right? So the number of people I found in the survey to be vaccinated. What did that end up being? 21, isn't it? And what is my test going to be? My test, remember, my test is, my alternative is p less than 0.53, right? So given this setting, my test is going to be, I'm going to reject h naught if t ends up lesser than some critical value c. Okay, so this is a very standard way of testing for the mean. Okay, so instead of using the mean, you could use the mean also. You know, you can make the test statistic as x1 plus xn divided by n. You can do that. And then also you can repeat a test like this, but you can also do it with t. It's not wrong. The test statistic actually has a binomial NP distribution, isn't it? And if that is less than C, I'm going to reject null. This is my test. Okay. How did I arrive at this test? This is a standard way to test for the left-sided mean, right? Mean being a little bit off on the left is what I'm worried about. So this is your standard calculation. Okay. If you want to find p-value and all that, you have to do with yeah. So I'll come to this question of how to reject or accept or something. Okay. So this is the type 1 probability. Okay. The first thing that I'm writing here, this guy. Okay. That is the type 1 error probability. Probability of rejecting the null given that the null is true. Okay. That is the type 1 error probability. Okay. Probability that I will reject the null given that the null is true. Okay. Now, notice what I'm doing here. I'm doing an approximation. Okay. And what is my approximation? I'm approximating the binomial distribution to be normal with mean 0.53n and variance square root of n times 0.53 times, what is 0.47? How did I get 0.47? It's 1 minus p, isn't it? 1 minus 0.53. So I got 0.47, right? Notice how I'm approximating this probability. Probability that t is less than c is fc of c minus 0.53 and by square root of this. Is that okay? I want my type 1 error probability to be 0.05. Is that okay? And from here, you can solve for C. You can do it like that. That's perfectly fine. So you can solve for C. If you solve for C, what will you get? I think what Harshita is saying is C ends up being 25.26, really? That high? I'm not sure if it will end up being like that. Yeah. So how do you set up this guy? So you're going to see the C equals this calculation, right? So it's going to be 0.53. 31 minus 1.645 times 0.4991. I think this is square root of 31. So you'll get some number here. Should the first equation have a positive sign? Yeah, so this will be 11.85. Okay, is that okay? Yeah, so it will be a negative sign, and yes, you have to take n as 31. We sampled 31 people, right? How many people you sampled? How many points you had in your sample is 31. Maybe, I don't know if you joined exactly a little bit late. I did this survey, live survey in front of everybody. So n equals 31, and I got 21 people saying they were actually vaccinated. So So this is how you calculate C. This is C at significance level equals 0.05 and n equals 31. Is that okay? So this is the textbook calculation. So this textbook calculation you should be very, very comfortable with. In most surveys, people do this to fix a significance level and then figure out a number of samples and then find this critical value. How do I find this critical value? That's the critical value that gives you a 0.05 type 1 error probability. Will we get FC value in exam? Yes, absolutely. In exam, you will get the FC value. Okay, don't worry about it. But I think, eventually people mug up these things, right? FC inverse of 0.05 is minus 1.645, right? How did we get 0.499? That is square root of 0.53 into 0.47, I believe. Isn't that correct? Square root of 0.53 into 0.47 ends up being 0.499, I think. Okay. Is that okay, Sejal? I hope you got it. It's right there, no? Yeah, square root will end up being like that. Okay. So this is the calculation for C in the first thing. Okay. So you see what will happen in the test, right? In our test, what will we do? RT, which is actually 21, is significantly larger than 11.85. So at a significance level of 0.05, we will accept the null hypothesis. So we do believe 0.53 is the correct thing in this setting. But of course, there's the practical issue of whether or not the sample represented the reality in India. But forgetting that, at least among the BSc population, we seem to have a very healthy vaccination ratio. But I'm going to ask the remaining 10 people, why are you not vaccinated? Okay, so first go and get vaccinated. All right, so don't stop from that. Okay, now let me come to the next calculation. Again, the next calculation is also very similar. Power also has a very, very similar formula. The power, this is power. Okay, power equals probability of rejecting the null given the alternative is true. That's sort of like the power, right? So it's a good thing, right? That's why you call it power. It's not an error in some sense. It's probability that you reject the null given the alternative is true. Again, that's a very, very, very similar calculation. You see how easy and repetitive these things are. Once you get the hang of it, you see actual calculation is very, very easy. Probability that you reject the null given alternative is true. Okay. Again, I use normal approximation here to simplify my calculation. I put a FC, that's normal approximation. C minus 0.45n divided by square root n p 1 minus p. And that has to be 0.95. I want a power of 0.95. Now 0.95 FC inverse. Again, I mean, these are things you should sort of remember after a while. It's 1.645. Okay. So you get 0.45n plus this guy. And that's the C from that thing. So notice what's happening here. You have two requirements and that gives you two different values for C, right? For the critical value. And it turns out if you want the smallest possible n, you have to equate these two possibilities. You'll see one will give you actually a lower bound, other will give you an upper bound. I do that in the lecture, you can go check it out. But you have two values for C. When rudimentary calculations, just equate the two values. You equate the two value, you will get finally 420. Okay. Now, what does this mean? Once again, what does this mean, right? It means if you have 0.53 as your claimed probability of whatever claimed fraction, and you want to test against it, and you want to be clear, if the actual fraction were 0.45, right? You want to make sure that you have enough samples that your test will still have a good type 1 error probability and type 2 error probability under both these fractions. Okay, so under 0.53, you have a type 1 error probability of 0.05, below 0.05. Even if it were 0.45, I will have a type 2 error probability of below 0.05, right? So I have a power of 0.95. If you have 420 samples, if you have only 31 samples, you will not have this kind of power. Your power will be, if you want a power of 0.95, your alternative has to be really, really far away. It's probably 0.2 or something like that. Okay, so so that shows you the power of having samples, enough samples. You can really distinguish between very close alternatives if you have more and more samples. Okay. I hope this calculation is clear. This calculation is bread and butter basic statistics. If you claim you did a course in basic statistics and you cannot do this calculation, people will not accept it. Okay, so you have to be able to do this very basic calculation. It's like saying I know multiplication, but I don't know tables. Okay, so you have to do this. It's a very easy enough arithmetic once you get over it. I hope it's clear. Okay. So that's the first question. The other few questions are very, very similar, and I've taken an unusually long time with the first one. It's okay. I think first time people are seeing it, maybe we can take some more time. Okay. How do you do p-value? So he's asking about p-value. So maybe I should talk about that. Just give me 1 minute. I'll go back to that. So p-value is, so in this formula for FC, right? In this formula, you simply put the test statistic that you get. Okay, so here you put C equals 21. Okay, you will get a value, right? That would be your p-value. It will be really, really low. If you put C equals 21, you will get a extremely low value, much lower than 0.05. When it goes very low, then you can be sure. Okay. Can you explain how to take the rejection region? So how did I get, so the question that's being asked by Reshmi is, how do you take this T less than C, right? So that comes from this hint, right? I'm worried about P being less than 0.53. So my null hypothesis P equals 0.53. I'm worried about P being less than 0.53. If P is less than 0.53, I'm expecting the count T to go lower, okay? So I have to reject my null, which is actually a higher fraction, if the count goes below some critical value, right? So that's sort of the left-sided nature of the test. Okay. If both are simple, how do you reject? So you always, your rejection region should not contain the null hypothesis. Okay, so that's maybe I'll just, these are all shortcuts you can use. So maybe I'll put it inside a box. Rejection region should not include null in some sense, right? So this is sort of like the way in which you can remember how to pick a rejection region. But of course, the test statistic may be a little bit complicated in practice, then you can't use this. But so your null hypothesis will give you a certain value for your test statistic, right? Expected value. You don't want your rejection region to include that. You want it to be away from that. So if you have two simple hypotheses, 0.53, 0.45, you don't want to pick a rejection region which will include 0.53, right? Because it's that's what you expect. So it has to be away from 0.5. Is that okay? So that's sort of like maybe a simple rule one can use. Okay, so we're going a little bit slow, so we should accelerate. Let's go to the next question. Okay, so the next question is, we see a press report which claims average age of students in IITM's BSc program is 24. Okay, so this is some news report that you're reading, and maybe one of us talks about the average age of students being 24. Okay, and you want to test this. Okay, what do I mean by testing this claim? You're going to go and do a survey like the survey I did a little while ago in this class. You're going to do a survey and then get some samples from the survey, hopefully IID samples. Okay, and you're going to test out something with respect to this claim. What will your null hypothesis be when you do this? Okay, null is sort of like the expected ground truth based on what you've read and all that. So here there is a claim that average age of students in IITM's BSc program is 24. So you're going to go and do a survey and ask people what their age is. So x1, x2, x3 till xn is the age of the n people you've got. And typical assumption is that these are normal with mean mu, variance sigma squared, right? Let's take that, doesn't matter. And then assuming something like that, what is your null hypothesis? You can of course assume any other distribution, doesn't matter. There are about 10 or 12 people have responded. Let me just see this. Mean equals mu equals 24, right? So you're going to take some x1, x2, xn, and then mu equals 24. Already put an alternative also. I haven't come to the alternative yet. This is the null hypothesis. Okay, so this is the easiest, right? So this usually is the easiest. Always go back to that sampling situation that I described. So before you jump into writing the null hypothesis, imagine that there is this x1, x2, xn, which are the results of my sampling survey that I did. And from there we get it. Okay. Suppose you suspect the above is not correct. Okay, notice my choice of the words in English. I'm not saying suppose you suspect the above is too high or too low. I'm simply suspecting that it is incorrect, which means what? It could be wrong on either side. It could be too high or it could be too low. Okay. So that's sort of the suspicion I have. Under that suspicion, what is a good alternative hypothesis in the testing framework that we have? Okay, already so many people have responded. Yeah, I think it's not good to say greater than or less than. It's good to say not equal to 24, right? So mu equal to 24 is not equal to 24. Yeah, good. A lot of people have got not equal to 24. Okay, so this is going to be a two-sided test. Okay, so two-sided test will have a different type of type 1 error probability calculation, a different type of power calculation. We typically don't do power and all that for two-sided test, but at least type 1 error probability is a little bit different, right? You can go both ways. What is the difference between the two suspicions from Q1 and Q2? So notice the difference, right? In the first times I said, I'm suspecting that fraction is too high. Okay. Why would you want to suspect that the fraction is too high? Why would you want the alternative to be less? I mean, I don't know. You can take it to be also greater and test it. But my statement was like that. I came from that point of view. So I want to test against the alternative that P is less than 0.4. So that was the way in which it went out. So in this problem, I'm simply suspecting that it's not correct. Okay. So is that okay? So that gives me a different type of an alternative. The alternative is not mu greater than 24 or less than 24. It's mu not equal to 24. It's two-sided. It could be, see, I'm saying either mu could probably be greater, maybe 27 or 28 or something. It could even be less at 21, 20, 70 or something. I'm just saying it's not around 24. That's my hunch. Okay. Don't ask me why I have that hunch. I'm the one who's setting the problem because I want a two-sided problem, right? So this will be a two-sided problem. Okay. I hope this is clear. Most people have sort of gravitated towards it. Okay, so we've already done the survey. So let's go to the survey. Let me show you the survey result. I already did a survey. 31 people have participated in the survey. 2 people actually have refused to give anything more than the first question. Okay, I think if you're still here, please fill that out, or maybe I should refresh this. Refresh the screen. Okay, I don't really get anything more. So 2 people have not given responses, so it's okay. I think it's okay. We'll live with this. It's not too bad. Okay. So I have 31 minus 2, right? So that's 29 or 33. Okay. All right. I'm getting more. 33 minus 2. That's still 31. Okay. I'm getting more. 34. All right. People are responding as I speak. All right. Good. But there are 2 people. I don't know who they are. They responded, but without answering the second, third, and fourth question. So that's okay. We can live with lesser number of samples. Okay, so let's see. We have 31 32 samples, or 31 samples, right? 33 minus 2, so that's 31 samples already. Sum is 925. 925 divided by 31. 925 divided by 31. What is that? Let's try that. Oops. I think I missed the equal to. 29.84. That's the average. Okay. So, all right. There's one more person who has done 35. Okay. So he's actually bringing the average down. So I don't know if I should include them or not. So let me include them. They're also here. So it's a bit rude not to include them. 2 to 35. That's 34 people, and 2 of them are not there. So we've got 32. 943 is the sum. Oh man, one more person has got an 82. Okay, all right. Okay, now I have got to include this. So let's include this. That's okay. I'm going to stop with this. I'm sorry if you're after this. Please don't put it down. 33 people are responding with a sum of 1025. That's 31. Oh my God, there's one more person who's got put 16 years. So I don't know. Let me just stop here. Okay. I apologize if I don't get there. So you saw the results of the survey. There were n equals 33, right? There were 33 samples, and the average ended up being 31. So should I compute anything else? What else should I compute? Should I compute something else? Variance. Yeah, exactly, right? Okay, so variance is and standard deviation, right? So I've got to compute standard deviation and variance. That's important too. So it's not enough to compute just this. So let's go to the responses. Wow. I think people are just adding more and more just for fun. I mean, please don't do that. It's too much for me to. Okay. Okay. So Puneet has given me an idea on how to do the other statistics. Okay. So I'll do that. Okay. So let me stop with the 33 samples that I already had, and sum was this. You can see the other statistics. Average is 31.08. Min max count. It's not quite giving me the variance, so maybe I should just explore. What is this? Variance. So let me ask for standard deviation. This thing is okay. Let's go back to the good old. I don't know if what it does to zeros. Okay, so okay, all right. So let's just take 14. Okay, so the standard deviation ends up being 14. Okay, so the average is 31 and the standard deviation is 14. That's okay. So let's just keep that. So there were, let's come back to the presentation session. So I needed to compute some things. I've computed it. Let me put that out on the chat here to everyone to see. So I got 33 samples. I've got sample mean of 31.06, doesn't matter, and the sample standard deviation of 14. Let's just take 14. Okay, you can take 31 and 14 if you don't like it. Is that okay? So that's my survey result. What is the test you will run? Okay, so that's the question you're supposed to answer in the slide. What will you compute from the data, and what is the test you will run? Okay, so let's see if you can come to that. What test will you run on this? What is this test called? There is a statistic you will take. You don't know the variance. You're making a normal approximation, which actually might not be a very good approximation in this case. But let's just say you take a normal approximation. And then, so somebody is answering in the chat. Please don't answer in the chat. You have to go to joinpd.com and then answer there. So anyway, Shailesh has given away the answer. Now everybody will do the actual response. So let me just quickly see the response. T-test, yeah. Whoever has computed it is writing that you do the t-test. And of course, what you have to do next is execute one calculation. So what are your assumptions about the data? That's one question which you can maybe skip, or you can talk about it while you do the calculation. But at a significance level of 0.05, what is your conclusion? Do you believe that the average age is 24 or not at a significance level of 0.05? Okay, so you got 31 with a variance of 14. Okay, what does that tell you? Does it tell you that 24 is okay, or for the mean, or it's too wrong, or what kind of confidence can you have? Okay. By the way, I mean, the actual data gives you 24 apparently. I did check with Bharti. The actual data is 24. So we can see if our sample seems slightly older in that sense, right? So the younger folks are not. So somebody wants the t distribution. You can leave the answer in terms of t32. Okay, or if you are enterprising enough, pull up a Python window and load SciPy stats, and you have access to t32. Okay, I think there are a few responses. I'll wait for a minute or so and we'll go on. So this is again an important calculation, and I'll tell you why this calculation is important. So this is what will happen, right? You will have a hypothesis about something, and you'll do a survey. You'll go ahead and find it, and you'll get something, right? And you have to figure out if that is if the discrepancy is there, is it statistically significant, right? It's an important thing to do. So today's accepted method for doing that is these kind of calculations: significance value, type 1 error, power. These kind of calculations are very, very critical, and you can question them. You should question them, but that's the philosophy of what is true, what is wrong. So in fact, the biggest question I would have here is the distribution is probably not normal for the age. Why would you guess the distribution is not normal? You can see that it'll be sort of asymmetric, isn't it? The number of people in the around 20 years are probably going to be very large, and there is a tail which slowly goes up. So normal maybe is not a good approximation here. So you get the sense of how the statistical procedure may be a little bit flawed, but doesn't matter, right? So what is accepted today is this sort of a procedure, and you can go ahead and do it. If you can better the procedure in this case, if you can do a better modeling for the age distribution, and then come up with a better distribution for your test statistic. Right now it's a t distribution. Maybe it's not t, maybe it is something else for this particular case. Then you can do a more accurate calculation. But all that is very difficult to do in practice. Usually people just stick to the t. Okay, so about 10 responses, close to 10 responses. So let me just show this. So most people are rejecting null, or they're not. Yeah, so it looks like people are rejecting the null. Seems like it. Okay. So there's an age is gamma distributed. Maybe you can pick a better distribution assumption. I agree with you totally. Okay. But we're just picking a normal distribution and t type assumption. So let me show you my calculation for this. What I have done here as a solution. So this is the assumption I'm making about my samples. Okay, so this, like I said, these are very crucial in practice, but in exams and first courses that you do in statistic, you should make these assumptions. You should be comfortable with these assumptions. You should know calculations with these assumptions. Okay, so the assumption I'm making is the n survey sample points I got were normal with mean, mu, variance, sigma squared, and my null hypothesis is mu equals 24. The average is 24. I'm suspecting to be incorrect, so my alternative is mu not equal to 24. And what were the results of my survey? We just did this, right? Let me just go ahead and write the results of my survey. My survey were 33, this was 31, and this was 14, right? So this is what it is. So I have to do sigma square is unknown here, so I need to do a two-sided t-test. And the two-sided t-test will reject H naught if mod t minus 24 is greater than C. Is that okay? I hope this is clear. So again, notice how this test is quite natural in this context, right? I want to see if my mean is 24. So I get my sample mean and see mod t minus 24 and compare it to some critical value. If it's greater than some critical value, I'm going to reject the null hypothesis, right? My t should not be too far away from 24. But now, how do I measure the statistical significance of these sort of things? I have these two probabilities, no, the two crucial probabilities. At least in this case, there's one probability, the type 1 error probability. What is the type 1 error probability? Probability of rejecting the null given that the null is true, right? How do I calculate this? This is probability of t minus 24 is greater than C given mu equals 24. Now here is where we use what we know about the distribution. If your original samples are IIT normal, then the sample mean when you don't know the variance, this 24 minus C by S by root n. So this kind of t minus 24 by S by root n ends up being as having a t distribution. Did I make any mistakes here? I don't know. It should not be 24. Is it just minus C or? Let me see. Okay. Okay, at least two people are agreeing with me.
Sir, t minus 24, if I take, then I already, that's 24 as minus, so.
Is that okay?
No, sir, not getting it.
Okay. I thought it was okay. Did I make any mistake here? So it cannot be 24 minus C. I'm sorry. I think it should be minus C by S by root n, right? Is that correct? Minus C. S by root n. I think somebody else said minus C. Yeah. So this should be correct. I'm sorry. Got misled by that. So the approximation is actually t minus 24 by S by root n is approximately t n minus 1, right? So this is the claim. This is important to know. So since already the t minus 24 is there, I have to divide by S by root n, and it's mod less than C. So this is correct. Okay. So I've not done the numerical calculation here because I couldn't do it ahead of time. I can do it now if you want me to, but I'll leave it like this. You compute this. It's a straightforward calculation. You put that in, you get it, and then this will work. Okay. Okay. So now I think this is correct. All right. Okay, sometimes it is difficult to identify test statistics. What is the general way to do it? I think generally people use likelihood ratio or a modification of it. Okay, there is a question from the original version. So I think I think the new version is correct. You can go and check with the the slides if you like. Maybe I should do that. Let me just make sure I get this right. Okay. Okay. So no, I think I see what you're saying. So it depends on how I do my test. If my test had been so say I'm doing a mod t minus 24 greater than c, right? See, if it were a right-sided test, and if I were doing t greater than c, then I need to bring in the t minus 24. But I think the distribution of t minus 24 by s by root n is approximately tn minus 1. So I think this is correct. So think about I see where you're coming from. So it's not that capital T itself has a Tn minus 1 distribution. The distribution is for T minus 24 divided by S by root n. Okay, so that has a approximate Tn minus 1 distribution. Okay. If my test were directly in terms of t, supposing my test is, t is between C1 and C2, or 24 minus C and 24 plus C, or something like that. If my test were directly in terms of t, then when I write the probability, I have to do this t minus C and all that. So I think this minus C by S by root n is correct. Because of this mod t minus 24. I will check on this again. If you still strongly believe, post something on the discourse forum, I will respond to it. Okay, I think this is correct. Okay, all right, so let's move on. Think about this later on. Okay, so anyway, there are 4 more questions to go and I have only 45 minutes, so we should go through. Okay, so we should get this. Okay, the third question is again something similar. We are now looking at quiz 2 scores. There are 2 subjects, stats 2 and maths 2. And the claim is the average marks in stats 2 and maths 2 are equal. Okay, that's the claim. We're going to assume that the standard deviation of the marks in both the subjects is known, and it is 23. Okay, this is actual data. 23 happens to be the actual standard deviation, in case you don't believe me. And you want to test the above. This claim is something you want to test. What will your null hypothesis be? So when I'm asking the null hypothesis, also think in your mind as to what the sampling situation is. Okay, what is going to be the sampling situation now? You're going to go ask N1 people who wrote stats 2 what their stats 2 score was. And you're going to ask N2 people who wrote math 2 what their math 2 score was. So x1, x2, x3 till xn1 is your survey results from N1 people who wrote stats 2. y1, y2 till yn2 is your result from N2 people who wrote math 2. Okay. Of course, you're now going to assume that the x is IID normal with mean mu1 and variance 23 squared. And y is also normal with mean mu2 and variance 23 squared. So where did all this come from? This is the standard setting, isn't it? In that setting, what will your null hypothesis be? Okay, so the claim is the average marks in Stats 2 and Maths 2 are equal. Okay, so usually in this kind of a testing framework, what will your null hypothesis be? Okay, so I hope this is clear to you. So this is sort of what is hidden behind some of these generic terminologies. Hopefully it should be clear to you. Okay, so more than 15 people have responded. Okay, so why are you equating standard deviation? So I've given you the standard deviation, okay? I've given you the standard deviation. I'm talking about the average marks being the same, okay? The average being the same. Standard deviation, you can assume is 23. There's nothing, I'm not asking you to test that. We'll test that later, okay? For now, I'm thinking about the average marks in Stats 2 and Math 2. They are equal is the claim. Somebody is claiming that these two are equal. In fact, they happen to be very close, by the way. So it will be an interesting thing to see what will happen here. So this is going to be some sort of a two-sample Z test, because you know the standard deviation and two different samples, two different surveys, and we did that just now. But anyway, I hope it's clear to you. There's no sigma 1 equals sigma 2. I'm not worried about sigma 1 equals sigma 2. Okay, so it's mu 1 equals mu 2. Okay, good. So I think that's something we did. Now here is a suspicion against which my alternative is going to be derived, using which my alternative is going to be derived. My suspicion is that Stats 2 has a higher average than Math 2. It's a very reasonable suspicion. I think many people might suspect that. I don't know. At least people in the Stats 2 class might suspect that. So it has a higher average than Math 2. Okay, maybe not. I don't know. I mean, I didn't write quiz 2, so I don't know. So in that case, what will your alternative hypothesis be? Okay. Okay, once again, remember the setting. I'm going to go and do a survey and verify these things, right? So assuming I don't have access to all the marks, I'm going to do a small survey, and like we did just a little while ago. So what will your alternative hypothesis be? Okay, so if you say mu1 is for stats, mu2 is for math, what's going to be your alternative? Mu1 greater than mu2. Okay, yeah, stats average greater than math average. Okay, good. So up to this point, everybody is clear on. Okay, so remember, I'm dealing with average marks now. My assumption is IID normal, two different samples, same variance, different means. Okay, don't go to P1, P2 and all that, right? So it's mu1 greater than mu2. Okay, so next is the survey results. Okay, so here's, I think most people have already given the survey results. So let me go to the survey results screen. Here's the survey results. See, this is where all this will hurt me, right? 74, I think, right? So 75, above 75, so I'm going to take it as 75. And then super good and COVID positive and all, I'm not going to take into account. So I'll take 33 just like before. And some people have not responded. I see 1, 2, 3. There are 3 blanks, 4 blanks. Okay, so since there are 4 blanks, we can go up to 38. Okay, so let's go to 4 up to 38. Then there are 4 blanks, right? So that's good. So 38. 38. Okay, it's not too bad. So what do I get? I get an average of 78.42. Oh my God, this is way above the average that it should be. I'm really shocked. I don't know what. So look at the count. Count is 33. So I think Google Sheet removes the blanks automatically, so you don't have to worry about it. Yeah, 101, 102 are invalid entries. I don't know who made that entry. Somebody has put in a comedy entry. And see, this is again a problem with actual surveying in practice. You'll get some comedy entries, you have to identify them. Your life will be lost in that, not in the stats calculation, unfortunately. But anyway, that's a different course. We won't do that in this course. This is the first course, so you assume everything is good. So whatever it is, I think this, so maybe I should restrict to a smaller sample. So maybe I'll restrict to a smaller sample. Let's go from here to the first 20 or so. Okay. The first 20, okay, it's 19. So let me just go through that. Oops. Let's participate. Okay, so here is 20. The average, look at the average, that's really high. I think only the good people are here. It's the average is definitely not 79. I know the average, it's close to 50. Anyway, that's the average, 79.95 for 20 people in Math 2. Okay, and is that enough? Is that enough? Do I need to calculate anything else beyond just the average for the Z test? That's enough, right? Sigma is given in this problem, 23 is given. Okay, so 79.95, somebody should remember that. So N1 equals 20 and mu1 equals 79.95. Wow, so it's for math. Okay, oh sorry, mu2, yeah, you're right, mu2. Okay, so sorry, I take that back. I don't know if I can delete it. No, it's not allowing me to delete that. Okay. So N2 equals 20 and mu2 equals 79.95. Oh my god, it's really high. Okay, so maybe we're going to, based on this sample, we're going to reject, I think. Let's see, here is another 20. Let's stop at 20 again. 76.8. Okay, there you go. N1 equals 20 and mu1 equals 76.8. There you go. So that's your data. In this two sample Z test, most people have guessed that it's this two sample Z test. Let's go back here. What will you compute from the data? What test will you run? Okay, what will you compute? We just computed, it's done. What test will you run? That's the question. Standard deviation is given to you and you have to test the null and alternative that we had. What test will you run? I think the answer also I gave you, two sample Z test. So most people are going to be writing that, I think. Yeah, two sample Z test. And what will be your test statistic? Test statistic will be X bar minus Y bar, right? So that's going to be your test statistic. Okay. What are your assumptions about the data? And at a significance level of 0.05, what is your conclusion? That's the question. Hope my solution to this is not flawed. Okay, people are responding already. Are we going to be rejecting? Probably. Are we going to be accepting? Maybe we accept it. I don't know. This is a bit strange. Okay, there are 5 responses, and in the interest of time, let me just go through and show you. Reject, accept, see. Okay, one person says reject, one person says accept, one person is still working things out. 23 by root 10, yeah, so that's sort of like where the answer should be. Absolutely, I think this formula for the critical value is correct. It's very good. So I think people have figured out how to do this. Let me show you my solution. This is how my solution looks. Once again, the setting for this is that there are N1 samples from one distribution, which is for stats, and N2 samples from another distribution, which is for math. Okay, this is the survey that I'm going to do. I've been told that the standard deviation is 23, and my null hypothesis is mu1 equals mu2. If you suspect stats 2 as higher average, mu1 is greater than mu2, and we did a survey, And our survey gave us N1 20, N2 20, and X bar was 76.8, and Y bar is 79.95. Okay, we're going to do a two sample Z test, and we'll reject H naught if X bar in favor of the alternative. We are rejecting H naught if X bar minus Y bar is greater than C. Okay, so I need to find the critical value, or you can do it using the p-value type of thing. If see the p-value is below your significance level, it's 0.05 or so. So this is the way to write it down. The most crucial thing is the formula for the type 1 error probability. What is the distribution for X bar minus Y bar? It's normal with mean 0, right? Under the null assumption, it's got mean 0, and variance is a little bit of a complicated variance. It's square root, it's sigma squared by n1 plus sigma squared by n2, right? So for sigma, you have to put a square root, and this is 1 minus fc c by this. So this is the formula that people are trying to use. If n1 and n2 are 20, you get a 10 here, so you'll get a root 10 multiplying the c. You can calculate it, and you will reject based on that. So I haven't finished the calculation. You can write it down and use the c value that you've got here. I believe you will be picking up one of these two. Okay. All right. So that's that question. Now there are two more questions of this nature. One is on. So I'm not going to go through details here. We'll go through. We can check this by putting C as 76. Yeah. P-value. Compare the p-value with 0.05. So Samit, you're absolutely right. So you can put C equals 76 minus 79. It's minus 3. And then you can check if your p-value is going to be above 0.05. What do you think the p-value will be? I mean, you will get something, and you can compare that with 0.05. If your p-value goes below 0.05, then you will reject the null hypothesis. Okay. If it is above 0.05, you will accept the null hypothesis. High p-value means you're close to null. Low p-value means you're away from null. Okay, so that's the way the convention goes. So you set it up like that, you get it. Okay, so you can do it like that, or you find the C and then go back and do the test. It's all the same. It's the exact same calculation. Okay. Okay. So here is the next setting. I claimed before the standard deviation of the stat 2 marks. Oh, does it depend on t greater than c or t less than c? I think in this case, it's okay. If you are doing a left-sided test, even then, as your c increases with your null hypothesis, you'll always be going lower, isn't it? So I think that thing of your p-value being below the significance level is okay, I think, for rejection. Okay. Think about that. To me, it seems fine. I've seen it being used like that all the time, but you can check that out. Think that too. Because see, if your test is left-sided, your null is on the right side, right? And as your C goes to this side, you'll only go lower and lower with your significance level, isn't it? Right, I mean, with your alpha, the type 1 error probability. So I think it's okay. I think if p-value going below the significance level, you reject null. If it goes above significance level, you accept null. Okay. Okay. So here is the next thing. I claimed that the standard deviation of the stats 2 mark is 23, right? And we did a sample of 20. We found the variance to be 14, isn't it? And all the survey has been done, etc. But now you may want to test that, right? So let's test that. Let's test if the standard deviation of the stat 2 marks is 23. It's actually 23. If you look at all the marks, it is 23. But this sample that we have here gave us a result of 14, right? So I think one safe conclusion is people who are attending the live session online are not representative of the entire class. I think it seems your average marks are 76, 79. Your standard deviation is much lower than the actual one. So it's a valuable lesson for us, I think, in terms of, I think maybe we should do more surveys like this during the live session to figure out what's going on. But it's, I think we should look at that more closely. Anyway, that's for another discussion. But in this case, we're coming to the standard deviation test. So your null hypothesis, once again, now again, remember what is your setting now? See, there is a statement here which says standard deviation of stats 2 marks is 23. So I'm going to go and survey a bunch of people who wrote the stats 2 quiz 2 exam. In this case, I surveyed 20 just now, but anyway, I might survey n. So I'll get n IID samples, x1, x2, xn. I'm going to assume they are normal with mean mu and variance sigma squared. And the hypothesis says, sigma equals 23, isn't it? So that's the hypothesis. It's easy enough. I think most people would have written that down, no problem. If you suspect the standard deviation is higher, your alternative hypothesis is going to be sigma is greater than 23. Then in this case, it's actually lesser. People who I should have suspected it's lesser, but anyway, it doesn't matter. So it's I'm doing sort of bad sampling as it turns out. But anyway, so let's just solve the textbook problem without worrying about the practical situation. So supposing you suspect the standard deviation is higher, the alternative has to be sigma is greater than 23. Okay, sigma is greater than 23 is your alternative. Okay, and then you will put it to the test. What will you compute? From the 20 sample points that we got, you will compute the sample standard deviation, right? And then once you compute the sample standard deviation, you can go ahead and do the test. What test will you run, by the way? Let me come back to this. What test will you run? For testing for the variance, we just quickly see. It's the chi-square test, okay? So there's only one sample here. Remember, I went back to just one sample. There's only statistics 2. You have to do a chi-square test for variance, okay? So keep that in mind. So let's do a chi-square test for variance, and you can do this, okay? So in the interest of time, I'm going to quickly show the answer, and just to reiterate, these are standard tests, and many tools may do it for you, but still it's good to see how they go on. X1 through Xn is normal with mean mu and variance sigma squared. Null hypothesis is that sigma is 23. You're suspecting it's actually higher, so sigma is greater than 23. Okay, and in a survey we found something strange. So this is a bad survey. I mean, I think we should do a different type of survey where a more representative group attends. But anyway, let's do this. Let's record the survey that we got. N equals 20. And the variance we got was 14 square. Okay, much lower. So the test you will run is the chi-square test for variance. You will reject H naught if S is greater than some critical value C. Okay. Now, once again, the result here is that n minus 1 times S. Okay, so the result is what? N minus 1 times S squared by sigma squared is chi-squared n minus 1. So this is the main approximation result. Okay, no, actually it's not approximate. It's an accurate result. So n minus 1 S squared by sigma squared is chi-squared distributed with n minus 1 degrees of freedom. So that's the main point here. So if you want to find the type 1 error probability, is probability that S is greater than C given sigma equals 23, right? Given so okay, so the chi-square distribution is with normal 0, 1 variables, something like that. So it works with the centralized version of the normal distribution. So it only depends on the degree of freedom. So, okay. So that's the answer to Shreya's question on why the chi-square depends only on degree of freedom. So it works with the normal 0, 1 distribution. So normally you will have mu and sigma squared. So that's why it does that. Okay. No, I think Deborah Smith is asking if it's a 2 sample test. This is just a 1 sample, right? I have only marks for stats 2, and I'm only asking about standard deviation of stats 2. There is no 2 samples. There's no one more survey where I asked about math 2. There's no x1, x2, y1, y2. It's only x. Okay, so it ends up being chi squared. So s greater than c, it's 1 minus f chi squared n minus 1, n minus 1, c squared by 23 squared, right? So s greater than c is the same as n minus 1. So you can calculate this. If you go below, if you can put c to be 23 or c to be 14, right? 14 squared, n is 20. You can calculate that. If you get a value below 0.05, you can reject the null hypothesis. Okay, so this is how you'll do a test for standard deviation. Let's go through. So Samit is asking about how you choose the alternative. The alternative should be your suspicion, right? You have okay. So wait. Okay, so maybe the wording is a little bit confusing. So in the first question, I said the report said the fraction is 0.53. Your suspicion is that 0.53 is too high. What does that mean? The actual fraction is lower, isn't it? Don't just focus on the too high, right? What is too high? The 0.53 that's reported is too high. Okay. So here I'm saying your suspicion is that the actual standard deviation is lower, which is the same as saying 23 is too high or something like that, right? So keep that in mind. Okay. So be careful. I mean, it's so to answer Samit's question. So in reality, you can have either hypothesis, right? So you should test for many alternatives. That's okay. You can do that. But in a problem, in a quiz like this, when I say I'm suspecting something, your alternative is your suspicion. Whatever is reported is your null. Your alternative is your suspicion. Okay. I hope that's okay. Okay, so that's the chi-square test for variance. Now let's move on to the last of the standardized tests in this session. So here we have 2 samples. Okay, so again, my claim in this problem is that the standard deviation of the stats and the math 2 marks are equal. Okay, that's my claim. Okay, so let's compute. Did we actually compute the standard deviation for both math and stats? I'm not sure if I computed the. I got something like 14. I don't know what I got. Yeah, only math we computed, I think. So let me just compute. Right? Okay, so this is coming out to be 19.8. So that's what the standard deviation for math. Stats is 14. Standard deviation of math is 14. Standard deviation of stats is 19. Okay, so this is what you get. Okay, from your survey of how many people did you sample? You sampled n1 equals 20, n2 equals 20. Okay, the one standard deviation was 14, another standard deviation was 19. Okay, given this. 33, is it? Oh no, I just did 20. Okay, I just did 20. Okay, let's just pick 20. So once again, what is going on here? What is going on here? Okay, so in case you're worried about what is going on here, right? If you take, even within your population, if you take different types of samples independently, identically, if you do it repeatedly, there will be variation. It's not that there'll be no variation. The thing is the variation according to the expected statistics, or is it too much, right? So that's what we are testing with these things. So keep that at the back of your mind, right? When you test in hypothesis testing, anyway you expect variation. It will not be exactly what you suspect or expect it to be. There will be variation. So the statistical significance is basically to determine, is the variation along expected lines or is the variation extreme? Okay, so that's what you're testing. These tests are designed for that. Okay, keep that at the back of your mind. It'll help you picture what's going on. Okay, so once again, that's the question. So what will your null hypothesis be? Once again, there are two samples here, x1 to xn1, y1 to yn2, y1 to yn2. One is the stats math, another is the math. And the claim is that standard deviation is equal. Okay, so in that case, okay, somebody has written down everything in the first one. Okay, but that's it's basically null hypothesis is equal. So here's my suspicion. My suspicion is stats 2 has a lower standard deviation than math 2. Okay, so if you suspect this, what will your alternative hypothesis be? Okay, so this is not two-sided, this is one-sided. Okay, sigma 1 less than sigma 2, that's good. Okay, so what will you compute from the data and what test will you run? Okay, so this is two sample test of variance, and that's called the F test. Okay, F1919, that's absolutely correct. You will test for two samples, I think. Okay. Okay, so you have to do the calculation now for significance level and all that. I probably have made a mistake in my solution. I'm not sure. Let me just test this. Oh, okay. Okay. So in my solution, I made a bit of a mistake. The mistake I made is something else, but doesn't matter. I think my solution is with respect to the higher mistake I made. Here I suspected that okay, no, sorry, this one. I suspect that stats 2's variance is higher. Okay, so in the question I asked you, it's lower. In my solution, I've made it higher. Okay, so it's the same, and we just did the survey. Both were 20. This one was 14, and this one was 19, right? Stats was 19, and math was 14. Okay, so you have to do the two sample F test. And the test statistic here is the ratio of the two sample variances, and you will reject H naught if it's too high, right? Greater than, usually you take it as 1 greater than 1, a little bit more than 1 plus CR, and Sx squared by Sy squared has this F distribution when the variances are equal of n1 minus 1 and n2 minus 1. Okay, and this one is greater, so it's 1 minus the PDF, so the CDF of the F distribution of 1919 and 1 plus CR. So you can put 1 plus CR equals this ratio, which is 19 by 14, and the p-value if that goes below 0.05, you can reject H naught. Okay, so this is the calculation that you do. Okay, so we're all set to go to the last question, and we're on time, which is good. So, I mean, I'm not giving you enough time for the calculation. I apologize. I think it's, you could do it. You will need to look up the CDF and all that, but I would also like to finish up with the questions. So here's the last question. It's a goodness of fit question. Since we are in the Olympics season, I thought I'll pick up a question from the Olympics. It might also help us make a prediction, right? So who knows? So here is a frequency table for Olympic medals won by India from 1972 to 2016. There's not too many Olympics in that period, but whatever data we could have, we have to work with that. So we work with this. The number of medals, if you want to look at 0, 1, 2, 3, 4, 5, 6. 6 is the maximum number of medals India won in this period. Greater than 6, of course. I just added just for fun. And this is my fit. I'm expecting a model which puts some weight for 0 and 1 because it's appeared so many times, and very few weights for 2, 3, 4, 5, 6, some p by 6. And the frequency is we've won no medals 4 times, 1 medal 5 times, 2 medals once, 3 medals once, and 6 medals once. So this is our the fit that we want. This is sort of like a model that we have, and the frequency that we observe from the data, and assuming independence and all that. Let's do all that and then come up with an estimate for this P using the maximum likelihood method. Let me see. I'll give you some time for this. Okay, so I've got about 8 responses. People are still, I don't know if many people are still around. Okay, so let me just see. 0.25, yes, 0.25 is the correct answer. 0.5, 0.75 is not correct. One nation, one medal. 2 by 3, 0.375. Oh, that's not correct. 0.25 is the correct answer. So there's various ways. You might remember how to do ML from the frequency table, right? So the way to think of this is we won 0 medals 4 times. So you're getting IIT samples. What are your samples? You got 0, 0, 0, 0 4 times, and then you got 1, 1, 1, 1 5 times, and then you got 2 1s, and then you got a 3, and then you got 6. Okay, so those are your samples. Okay, you've got how many samples? You got 12 samples. 0 occurring 4 times, 1 occurring 5 times, 2 occurring once, 3 occurring once, 6 occurring once. Those are your samples. There are only 12 samples. Okay. So what's the likelihood of these samples? It's 1 minus p by 2 raised to the power 4 times 1 minus p by 2 raised to the power 5 times the p by 6, another p by 6, another p by 6. That's the likelihood. So it will be actually proportional to p power 3 times 1 minus p power 9. So whenever you have p power 3, 1 minus p power 9, the ML estimate is direct, right? It's 3 by 3 plus 9. You can work it out using log and differentiation and all that. It'll be 3 by 3 plus 9. It'll be 1 by 4.25. Okay, so that's a quick way to arrive at this answer. Okay, so always imagine the sampling, you'll get that. Okay, so the next thing is this a good fit, right? Is this a good fit using the chi-square test? You may find a very surprising answer. I think it's a very good fit actually. Maybe I have a good model to predict what our number of medals will be in the Olympics, and actually the chance that we'll get greater than 6 medals, it seems like p by 6, so that's 1 by 24. Okay, is that good? Maybe a bit lesser. We have a good chance to, we've already crossed 1, isn't it? We're already at 2. There's a good chance we'll get to 4, 5. So this year looks like we may be in the vicinity of 5 or so. Let's see how it works. So the chi-square test, you have to find the expected numbers. Then the chi-squared goodness of fit test has a certain test statistic. We are at 3. Okay, all right, good. This is a very simple-minded model. I'm sure this model is totally crazy. It's just for doing calculations. Okay, nobody's responded so far. I think everybody's just waiting for me to show the solution. Anyway, we're coming close to the end of the 2 hours. So let me just maybe go and show what solution I have. So 1 by 4, and now a couple of calculations to know here. What is the degree of freedom for the chi-squared? It will be actually what? It's k minus, k is 8, right? There are 8 different buckets that falls into. So the degree of freedom will be 7. Okay. And the chi-squared expected numbers is this will be, if you put 1 by 4 here, you get 3 by 8. 3 by 8 times 12 is 4.5, 4.5. And all these guys are 0.5. So if you do the chi-squared statistic, you get 28 by 9. So some 3.11 thing. The p-value is probability that p is greater than c, given the fit to this. And this t, a good model for this t is that it's chi-squared 7. Okay. And so you just put in 28 by 9, you get actually 0.874. This is quite a high p-value, indicating a good fit. So that's why I said it seems to be a successful model, at least for this kind of a thing. Okay, this is how you do this calculation. I hope this is clear. The goodness of fit is relatively easy. You just find one of the parameters and look at the expected numbers, compute a certain statistic, and that has a distribution which is chi-squared. Okay, so this concludes our session for the day. It's a little bit under 2 hours, but I hope it was interesting. It's a mix of, we did a live survey, which we haven't done so far. So that was good to see. I could have even asked you for a prediction, maybe. I don't know what prediction would be interesting. I know the tests are upcoming. It's just a few days. So no. This is my last live session for this Stats 2. I've covered everything. After this, we will have classes from the instructors. Thanks for everyone who was here. Solution for the mock. Can you ask in the discussion forum, please? The discourse forum. I don't have an immediate knowledge of this. Okay. Thanks everyone for attending. All the very best for the exam. I hope all of you do well and carry on with the program and have a good time. Okay, stay safe. We're still not totally out of the woods. Stay safe and have a good time. Can we have an NPTEL session after enter? NPTEL session meaning I didn't understand what you meant by NPTEL session. I hope. Last minute tip for the exam. I actually don't have any last minute tips. I think if you've been preparing with your assignments and doing all the assignments well, and you should be good. I think if you should have very good preparation with that, and you'll do well. Okay. NPTEL courses for extra credit. So that comes in the third year. I think it doesn't come till now. So you have a considerable long time. But I know you can start taking it from now. That's true. That's also true. Maybe that's why you're interested. I think you should write to support or someone. I mean, I think some resolutions were passed. The list of courses must be out, I think. Isn't it? If it's not there, I'll look into it. I'll find out what the status is. I don't know the exact status, right? Okay. Okay, all the best. I hope all of you do well. Thank you very much. Okay, bye.